Okay, first video of the first week. Okay, so let's see. We'll be talking about the segment addition postulate in class. Okay, and I'm looking here. I have a segment that goes from A to C. So I've got segment AC, and I have point B, which is somewhere in between A and C. Okay, so by the segment addition postulate, if I take this length, whatever it is, plus this length, whatever it is, it gives me the length all the way across. So I would have the length of segment AB plus the length of segment BC equals the length of the segment all the way across to AC. Okay, so there's my relationship that exists in this diagram. Okay, so we should assume that 2x plus 5 represents AB, x plus 3 represents BC, and going all the way across is represented by x plus 15. Okay, so we substitute those expressions in here. AB is 2x plus 5 plus BC is x plus 3 equals AC, which is x plus 15. Okay, so we just solved that equation. So notice the right-hand side, there's no simplification to do. The left-hand side, we should simplify, collect similar terms. 2x plus x is 3x, 5 plus 3 is 8, and just bring the x plus 15 down. Okay, and then we solve. So if we subtract 1x from both sides, that leaves me with a 2x over here on the left. And if we're collecting the x's on the left, we collect the constants on the right. So I should subtract 8 from both sides. So 15 minus 8 is 7. And then divide by 2. So I get x equals 7 halves, or 3 1/2. Okay. And then let's see if things work out. Okay, so we want to check this. And then obviously we're looking for AC here. That's what it wants us to find. So let's see if this value, 3 1/2, works out in this situation. So I'm going to check. Okay, my AB is 2x plus 5. So I substitute 3 1/2 in there, and I get 2 times 3 1/2 plus 5. 2 times 3 1/2 is 7, so I get 7 plus 5, so I get 12 here. Okay, so AB is 12 units long. Okay, let's go BC. Now BC is x plus 3. So I put the 3 1/2 in for x, and I get 3 1/2 plus 3. And when I add those, I get 6 1/2. Okay, so this guy right here is 6 1/2. Okay, let's check AC going all the way across. Okay, that's x plus 15. Okay, so if I put 3 1/2 in there, I get 3 1/2 plus 15. And when I add those, I get 18 1/2. Okay, so AC is 18 1/2. Okay, so we take a look and you say, okay, well, if I take the 12 and the 6 1/2 and add them together, do I get 18 1/2? Absolutely. Okay, now it wants AC, so here is my final answer right here. Okay, and we're in good shape. Okay, first one down. Let's try another one like that. Very similar type diagram. Okay, we have the segment going from H to L, and K is on that segment in between H and L. So by the segment addition postulate, this segment length plus this segment length should be equal to the length of the segment all the way across. So I'd get HK plus KL right here equals the length all the way across, which would be HL. Okay, so that relationship exists in this diagram. Okay, so once again, we should assume 8x minus 9 is the length of HK. We should assume 6x is the length of KL, and we should assume 6x plus 9 is the length of HL. So we substitute these into this relationship. HK is 8x minus 9 plus KL is 6x equals HL, which is 6x plus 9. Okay, simplify the left-hand side by adding similar terms. 8x plus 6x is 14x. And then just bring down the 6x plus 9. Okay, so I got to get the x's together, so I'm going to subtract 6x from both sides. So that'll disappear. 14x minus 6x is 8x. And then that means I have to add 9 to both sides, so that goes away. 9 plus 9 is 18. And so I'd have to divide both sides by 8, so I get x equals 18 over 8. Now that's not a reduced fraction, so if I reduce it by dividing both of them by 2, I'm going to get 9/4. Now 9/4 is the same as 2 and 1/4. So it looks like x is going to be 2 and 1/4. Okay, I'm going to want to check that within the context of the problem to make sure things work out. And if it does, then I can find HK. So let's start with HK. Okay, so here's my check. Does it work? Okay, HK, which is 8x minus 9. And so I substitute this 2 and 1/4 in there. So I get 8 times 2 and 1/4 minus 9. And I can go to my calculator and make sure that I'm getting the right answer. So we get 8 times 2 and 1/4. Okay, hit enter, and then subtract 9. So I'm getting 9 here, okay, for HK. Now we have to do KL. So KL, which is 6x. Now I substitute the 2 and 1/4 in there, so I get 6 times 2 and 1/4. And then we can, again, go to our calculator. So I go 6 times 2 and 1/4. And I'm getting 13 and a half. Okay, this is 13 and a half. So far, so good. Let's see, and then I go to HL. Okay, HL. Now, HL is 6x plus 9. So 6x plus 9. So I get 6, and I substitute the 2 and 1/4 in there. Plus the 9. Now, I already know that 6x is 13 and a half, so this is 13 and a half. So we get 13 and a half plus 9. And when I add those, it looks like I'm going to get 22 and a half. Okay, so let's see what happens. Let's see if this works out. So my HK is 9 right there. My KL is 13 and a half right there. And my HL is 22 and a half right here, 22 and a half. And so this has to work out. So if I go 9 plus 13 and a half, and you can check on your calculator when you add it, you will definitely get 22 and a half. So we're in good shape. So let's see, it wanted me to find HK. Okay, so here's my final answer. HK is 9. Okay, we're good. Okay. Okay, let's see, midpoints. Well, we'll be talking about midpoints this week in class. And it says that S is the midpoint of segment RT. And notice I don't have a diagram, so I'm going to make myself a diagram. Okay, so I have segment RT. Okay, so I'm going to draw a segment. I'm going to put R at one end and T at the other end. So I have segment RT. And it says that S is the midpoint. That means that it has to be right in the middle. Okay, so S is the midpoint. So that means that this segment right here from R to S has to have the same length as this segment, ST. So I have to have RS, the length of segment RS, equal to the length of segment ST. And notice that you are using a different relationship here than the segment addition postulate. Okay, so if I know that RS is 19x minus 10, this is 19x minus 10, and ST is 10x plus 35, well, the fact that S is the midpoint means that these two segments have to have the same length. Okay, so if I set these two equal to each other, I can solve for x. Okay, so we say RS, which is 19x minus 10, equals ST, which is 10x plus 35. And then we solve. Okay, so I'm going to subtract 10x from both sides, so this is going to disappear. 19x minus 10x is 9x. So if I collect the x's on the left, I got to collect the constants on the right, so I'd have to add 10 to both sides. So 35 plus 10 is 45. And then I divide both sides by 9, so it looks like x is equal to 5. Okay, now notice it wants us to find RS and ST, and they should have the exact same length. So let's see. Okay, let's check this. Okay, so I'll do RS first. So RS, which is 19x minus 10. So I get 19 times 5 minus 10. And let's see, that would be 50, that would be 95 minus 10, which obviously is 85. So hopefully I get 85 for ST. Let's check ST. And notice ST is 10x plus 35. So substituting the 5 in here, I'm going to get 10 times 5 plus 35. Well, 10 times 5 is 50 plus 35, and that gives me 85. Okay, so let's see. It wanted RS and ST, so I've got my answer right here. They're both 85, which should work out. Let's try another one like that. Okay. Okay, now notice I have the two tick marks here and here, so that means that segment RS has to be, or has to have the same length as segment ST, so that means S has to be a midpoint. So right in the diagram, it tells me that RS is equal to ST. So I have my relationship, and it wants me to find RS, ST, and RT. Okay, well, 17x minus 7 is the length of RS. 13x plus 5 is the length of ST. So if I set these two equal to each other, I can solve for x. Okay, so RS is 17x minus 7, and ST is 13x plus 5. Once again, solve it. Okay, so I'm going to subtract 13x from both sides, so this just disappears. 17x minus 13x is 4x. Okay, so if I collect the x's on the left, I have to collect the constants on the right, so I'd have to add 7 to both sides. So that disappears, and 5 plus 7 is 12. And then we divide both sides by 4, so we get x equals 3. Okay, so let's see if that works out. Okay, so my check. Okay, I'm going to have to figure out RS. I'm going to have to figure out ST. And then it also wants RT, what it is all the way across. Okay, so let's see. RS is 17x minus 7. I substitute the 3 in there. So I get 17 times 3 minus 7. And let's see, that would be 41 minus 7? No, 51, I'm sorry, 51 minus 7. So that ends up giving us 44. Okay. ST is 13x plus 5. Substituting the 3 in here. So I get 13 times 3 plus 5. And let's see, 13 times 3 is 39. plus the 5, so that gives me 44. Okay, so I should end up with RS and ST having the same length, and I do. So let's see, that's 44, and that's 44. And so if I want RT, I can add these all the way across. So RT would just be my 44 plus 44, which gives me 88. Okay, and notice it wants all three of them, so this is my answer right here. Okay, got all three lengths. Okay, that one went well. Then we come down to this last one. Okay, so let's see. It wants me to find the length of AB right here. Wants me to find the length of BC right here, and wants me to find the length of CD right there. Okay, so it looks like going all the way across from A to D is 10x plus 3. And it looks like the distance from A to D would be the sum of these three smaller distances. So it looks like I have that relationship where I take the length of this segment, AB, plus the length of this segment, BC, plus the length of this segment, CD, and that'll give me the length all the way across from A to D. Okay, so there's my relationship. It's just a matter of just substituting things in. So let's see, AB is x plus 4, plus BC is 5x minus 1, plus CD is x plus 6, equals AD going all the way across, and it tells me that's 10x plus 3. Okay, so we simplify the left-hand side, so x plus 5x plus x, that's 7x. And let's see, 4 minus 1 is 3, 3 plus 6 is 9. And then over here I have my 10x plus 3. Okay, so I'm going to subtract, let's subtract 10x from both sides, so that goes away. So 7x minus 10x is negative 3x. That means I have to subtract 9 from both sides, so 3 minus 9 is negative 6. And then I divide both sides by negative 3, so I get x equals 2. And let's see what happens here. Let's see if it all works out. Okay, so I got to check it, as well as I got to come up with these three answers. So AB is x plus 4. So substituting the 2 in there, I get 2 plus 4, which obviously is 6. So it looks like this guy is 6. Okay, then I'm going to do BC, which is 5x minus 1. So I substitute the 2 in there, so I get 5 times 2, okay, minus 1, which obviously gives me 10 minus 1, which is 9. So it looks like this guy is 9. And then I have to do my CD, okay, which is x plus 6. So I substitute the 2 in, I get 2 plus 6, which obviously is 8. Okay, so let's see, this guy is 8. Now I got to make sure that the 10x plus 3 works out with all these numbers. So I've got to do AD all the way across. So my AD, which is 10x plus 3, I substitute the 2 in for x, so I get 10 times 2 plus 3, which is 20 plus 3, or 23. Okay, so let's see, this is 23. So let's see if this works out. 6 plus 9 is 15. 15 plus 8 is 23. So it works out. Okay, so let's see. I've got my answer right here. Okay, everything works. Okay, that'll be the first video for this week. Second one coming up soon.